Hello friends, welcome to this video about binary shifts. The objective of this video is to explain what is a binary shift, which types of binary shift exist, and their circuit diagrams. In this set of videos dedicated to the binary multiplication, the concept of binary shift is frequently used. The present video is issued to further clarify this concept, explain their significance, and learn how to perform the shifting. Throughout this video, your comparison with the more familiar decimal numbers shifting procedure may be helpful for your understanding. A binary shift is a modification of a binary number where all its bits are moved forward or backwards, but always maintaining their consecutive order. There are two main types of binary shift: right shift and left shift. When moving the bits, some vacant bits are created. Depending on the bit that is used to replace the vacancy, you can distinguish between logic shift and arithmetic shift. Before going further, let's see some examples. This is an example of right shift, and this is an example of left shift. As you see, the shift pushes the bits to one side or to the other. Note that the bit that is moved out by the shifting is ignored and dropped. Ignore and dropped. In all cases, the number of bits is kept the same before and after the shifting. 6 bits, 6 bits. And after a shift, the value of the number changes. Now, let's see the difference between a logic shift and an arithmetic shift. In a logic shift, each bit is moved one position to the right. The less significant bit that now is pushed out of the bits is discarded. And the new most significant bit is filled with a 0. In an arithmetic right shift, everything is the same, but the new most significant bit is filled with a copy of the previous most significant bit. Example: this bit is a copy of the previous most significant bit. And second example, this bit is a copy of the previous most significant bit. So the difference is that in a logic right shift, the vacancy that is created at the most significant bit is filled with a 0, whereas in the arithmetic right shift, the vacancy is filled with the copy of the previous most significant bit. The arithmetic right shift is mainly used when working with signed numbers, because it has the advantage that it preserves the significance of the signed bit. In other words, if we would not repeat the most significant bit, either 0 or 1, the number would pass from positive to negative or vice versa. Remember that in a signed binary number, if the signed bit is 0, means the number is positive, and if the signed bit is 1, the number is negative. Let's see now what is the difference in the case of a logic left shift and an arithmetic left shift. In a logic left shift, each bit is moved one position to the left. The most significant bit that no is pushed out of the n bits is discarded. And the new less significant bit is filled with a 0. In an arithmetic left shift, everything is the same, but the new less significant bit is filled with a copy of the previous less significant bit. Example: the new less significant bit is filled with a copy of the previous less significant bit. And another example: the new less significant bit is filled with a copy of the previous less significant bit. Probably you have already noticed that in some cases there is no difference between logic shift and arithmetic shift. The resulting number is the same. This is the case here and here. Note that this occurs for the left shift when the less significant bit of the number is 0, here and here. Both shifts produces the same number because in both cases the vacancy created in the less significant bit is filled with zeros. I'll let you find out what is the other case when there is no difference. What is the significance of a binary shift? A right shift is equivalent to divide the binary number by 2, and a left shift is equivalent to multiply a binary number by 2. More generally, each binary shift can be used to multiply a number by a power of 2 or to divide a number by a power of 2. The exponent of 2 to the power k indicates the number of shifts to perform. Example: a left logic binary shift of one position would convert the number 22 to 44. And a left logic binary shift of two positions would convert the number 22 to 88. Now the question is how to perform the shifting in a computer. We can imagine a binary shifter as an operator that takes two operands. One operand commands the direction of the shift, left or right, and the second operand decides the number of places to shift. This is a general block diagram of a binary shifter. So, a binary shifter is a logic circuit that takes a binary input A and performs either a left shift or a right shift depending on the value of another input D. K indicates to the counter the number of shifts to perform. This is an example of a binary shifter for the case of a 5-bit binary number. When input D equals to 0, the circuit performs a right shift, and when D equals to 1, performs a left shift. A are the bits of the number to be shifted, and S are the bits of the output result. Let's see with an example how the binary shifter works. The input number is 10110. If we put D equal to 0, this means we asked for a right shift. So the solution should be 01011. And effectively, the result given by the circuit is correct. In blue, you can follow in detail the binary logic of the circuit process. If we put d equal to 1, this means we ask for a left shift. The solution should be 0, 1, 1, 0, 0. And effectively, the result given by the circuit is correct. With the digits in blue, you can follow in detail the binary logic of the circuit process. Remember that in binary, the AND gate behavior is analogous to multiplication, and the OR gate behavior is analogous to addition. At the end of this presentation, I join an attachment as a reminder of these behaviors. In summary, in a binary shift, all bits are moved forward or backwards, always maintaining their consecutive order. There are two main types of binary shift: right shift and left shift. There are two modes of binary shift: logic shift and arithmetic shift. The difference depends on the bit that is used to replace the vacancy. Logic shift is filled with 0. An arithmetic shift can be filled with 0 or 1 depending on significant bit. A binary right shift is equivalent to divide the binary number by 2. And a binary left shift is equivalent to multiply a binary number by 2. In this video, examples of a detailed binary shifter circuit have been presented for your understanding and reference. That's all for today. Thank you very much for your attention. Have a nice day. If you like this video, please hit the like button and subscribe for more videos. This is the attachment that is joined as a reminder about the AND and OR gates behavior. Thank you again for your attention.